Hello friends, last period we already started the third chapter from the paper 2nd organic chemistry for the F.Y.B.Sc. that is CH102. Now last period we already discussed about the various isomerisms. There are major two types of isomerism: structural isomerism and stereoisomerism. And actually we will start the stereochemistry from today, and before starting the stereochemistry we will discuss about the representation of organic molecules. Now you know very well about this. Organic compound contain carbon atom and generally it is in sp3 hybridized generally, and when we consider this carbon atom is in sp3 hybridized, it having the geometry tetrahedral. It having the geometry tetrahedral, and when you consider the tetrahedral geometry, so many times we draw this tetrahedral geometry on the paper, but in the 2D form. In the 2D form, because our plane having only, we draw only two axes, x and y axis. Z axis is not possible, so it is 2D. So we convert the 3D structure into 2D structure, and there are various methods to represent this organic molecule on the paper or on the blackboard. Now there are various methods to draw this organic molecule on the paper. There are 2 to 3 methods. First method is that dotted line wedge formula. In other way, the name of this system is flying wedge formula. Then second is that Fischer projection formula. And third one, sawhorse projection. And last one is Newman projection. Means representation of organic molecule is by 4 ways. That is dotted line wedge formula, Fischer projection formula, and sawhorse projection, as well as Newman projection. Now today we will see one by one here. Now first one is, for this we take example. Now in this case, these wedge bonds are coming towards are coming towards us, means like this. Actually this bond is coming towards us, and hence this is shown by wedge. And these dashed lines represents backside the plane, backside of the planes, means these dotted line bonds are backside of the paper. Suppose you consider this is plane and this bond is backside of the paper. Means suppose we consider here this one is back side and this one is front side. These front side bonds are shown by wedge, and back side of the plane or the blackboard or the paper, these bonds are shown by the dashed lines, and those bonds are present on the plane. This is shown by these solid lines. Means solid lines represents bonds on the plane. Means with the help of these wedge bonds, with the help of dash lines, and with the help of these solid lines, we can present the 3D diagram into the 2D diagram, and hence this is called as dotted line wedge formula. Now we will rewrite this one. Means solid line represents in the plane of the page or blackboard. Okay, then wedge is like a triangle. Wedge comes towards out of the plane. Means it is in front. And dashed lines goes backward out of the plane. Means behind. Means with the help of this representation, we can draw tetrahedral structure on the blackboard as well as on the paper. Now second method is Fisher projection. Second method, Fisher projection. And this can be discovered by the Fisher scientist. What happened in this case? Now here we consider the one example where A and B are in the plane. This D backside of the plane, and this wedge is in front of you. And suppose we consider here human eye human eye see this compound by this direction, and what happened here? This human thought about this structure like this way, means here C and D, C bond is on the left hand side. Here when we see on this side, C are on the left hand side and D on the right hand side, and this A is above and B is below. When we see this human can see this on this side, and this can be converted into this way: A, B, C and D. Means here A and B are in the plane, and C are back side of the plane, and this is back side of the plane, and this one is in front of you. This is in front of you, and this can be converted into this one imaginary diagram, and then this one is converted into this way. Means A and B are in the plane, C in front of you and D back side of the plane, and this can be discovered by Fisher, and hence this type of representation called as Fisher projection. Then third one, Sawhorse projection. Now in this case, when we see when we go step by step here, now this representation is by flying wedge formulae, okay, and this can be converted into Fisher projection. This is Fisher projection. Now this one can be converted into Sawhorse like this way. Now here CWH, and here OH, H, here H and OH, and this is the sawhorse projection. Sawhorse projection. And already today we will discuss the 3 methods. Okay, thank you.